Hello, good morning, good afternoon, good evening from whichever part of the world you are joining us today for this webinar on iDrawings for AVEVA migration. This is Rangan here, or JK. I'm the Executive Business Development and Sales Advisor to IPS, as well as the Managing Partner of IPS in India. I'm joined here by Dennis and Mike, who will help us with the live demonstration, and also by Benji and Adeline, who will be administering this whole event. So a little bit rules on the administration. There's a QA panel. You can send in your questions there. We'll try to address as much as we can at the end of the webinar, but excuse us if we are not able to, but don't mind that. We will send you an email with the answers. So there you go. And there will be 3 poll questions in between, so I request you to answer them. That's all. So let me start. So IPS is an artificial intelligence and technology solutions and services company headquartered in Vancouver. Next slide, please. Our AI has helped turn billions of drawings and documents into the most valuable asset, data. Next slide. We develop AI technology using machine learning, deep learning, natural language processing, and image processing technologies. The main intent being to digitalize engineering drawings and documents, such as PNIDs, data sheets, extract information from those, and use that to recreate the drawings in destination CAD systems like AutoCAD, SPPNID, and AVEVA. And today's key focus is going to be migration to AVEVA. Okay. We are located, headquartered in Vancouver. We have a fully owned subsidiary in India, in Pune, and we have recently opened up another office in India at the National Capital Region, and we have a full-blown engineering center in Cebu, Philippines. Okay. Yeah, this is our engineering platform. These are all the products that we already have, and today our main focus is going to be around iDrawings, PNID. Yeah, keep clicking till the whole slide is complete. Essentially, we are building a cloud-based AI platform, looking at the documents and drawings from various domains, such as operations, engineering, procurement, and maintenance. Again, the main purpose is digitization or design automation or management of change. We build our AI engine to extract data from various sources that come from engineering and operations, drawings, and documents. And then we structure them into a data structure. And through our AI solution, we integrate to 3D models for the purpose of digital twin, or integrate them with engineering design software like AVEVA, AutoCAD, SPPNID, or bring them into asset management systems or to SAP. Okay. Yeah, next. So these are this is a snapshot of our key global customers and partners. They are not all, but just a snapshot. Next. So when we done a comparison between iDrawings, using iDrawing solutions for PNID migration vis-a-vis using manual redraw, we can easily say that if manual redraw takes anything between 10 to 18 hours per PNID, using our solution and the manual tidying up, this time will be reduced to anything between 1 to 5 hours. What you really need to bear in mind is you cannot get 100% with AI, and that's not the intent as well. The main intent is to give you a value proposition, which is to bring down your time and bring down your costs for migrating legacy PNIDs. So this is the main intent, and we hope this is get satisfied when you use our product. Okay. Next. Okay. Very briefly on the workflow, you'll see this in the live demo as well, but the workflow is basically that we have built an AI model that is based on PIP practices, which is used to recognize symbols, texts, lines, tags, and components. And customers, as you're aware, use their own typical standards, symbology, as well as tagging conventions. And using these inputs, we convert the PDF input drawings into destination CAD systems that the customers ask for. So today we are going to talk about migrating to AVEVA. Okay, next. So the latest version of this AVEVA P&ID generation was released in 2023 September. It has an advanced user interface for project setup. As you will see that it has a generic AI model which can be configured on specific engineering standards, and it has got a new interactive user interface as well. So you can see all that once we get to the live demo. Next, please. Yeah, so the first question. So Benji, can you help launch the first poll question, please? Okay, the first question is, what is the reason you need to recreate P&IDs in your company? So is it digital transformation mandate or a new capital project or operations management? So we'll give it a minute so that each one of you is able to answer. Okay, Benji, I think it's time to close. We'll show the results.
Okay.
Yeah, about 66% of you have said digital transformation. Yeah, here are the results. 11% new capital project, 22% operations management. Great. Okay, let's go ahead. Next, I think we have this live demo. So I would invite Dennis, the product owner. Dennis is the product owner for iDrawings, and I would invite Dennis to show us a live demo along with Michael. Dennis?
Yeah, thank you, Jiggy. Yeah, Mike, can you share your screen? Yeah. Can you hear me, guys?
Yes, yes, we can.
Okay, yeah. Good day, everyone. Okay, I'll be demonstrating today the work process of the iDrawings PID product. Okay. So to begin with, this is our cloud-based application where you can access through cloud login. It can be hosted on client internal cloud or deployed on our server. So to ensure smooth access to the cloud server, it is recommended to open the server in an incognito window to prevent any potential cache memory issues. Okay, and then enter the login credentials. Okay. Once logged in successfully, you will be directly taken to this product dashboard screen. You can view all the IPS products. And for this presentation, our focus will be on the iDrawings PID product. So yeah, to clicking this product dashboard, this will go to the project dashboard, where we can access links to all the project hosted on this production server. Additionally, on this screen, we have the ability to create, modify, delete, or clone any project, provided they adhere to the same standards. Okay, for example, if you have 100 to 300 drawings adhering to the same standard, we can utilize a single project model. However, if you have drawings following multiple standards, we can create separate project models to accommodate each standard. So this is the project model. So example, if you have three standards, so you can create three different project models here. Okay, so if you take a look, okay, you will see that there's already one existing project displayed on the screen. This project was created earlier to save time for this demo. However, for the purpose of this presentation, we will demonstrate how to create new project. Okay, so by creating new project, okay, click this create project button. Okay, okay. So in this screen, this will be used to capture basic information, project information such as project name, project number, project description, project scope of work, client, the product, which is the iDrawings PID, and the users that will be working for this project. Okay, so for this demo, we will use the existing project setup where we can already populated those informations there. Okay, so okay, let me go back quick. I think this one. Okay, so this is this first screen earlier that I showed to you. This is the project information screen. Okay, once we completed this information for this screen, we can proceed to the next screen. Okay, so this will be the document discipline configuration. This screen already comes with default configuration that supports two different pipelines or processes and serves the purpose of uploading two different input datasets. One is the PDF. So PDF supported the discipline pipe process engineering and the document type process engineering piping and instrumentation diagram. Also, this PPID dump Excel or Excel file format, which contains extracted data from PPID to be used for AVEVA and PNID conversion and ACPID conversion. So this will support on the project management and engineering discipline, and the in project management and engineering's PPID dump Excel document type. Okay. See on the next screen, this will be the PBS screen, which stand for Plant Business Structure, supports various templates that we use for the iDrawing product. So the on the next screen, okay, this will provide detailed information based on the selected PBS or Plant Business Structure. Okay. So next will be the IPS tag class information. On this screen, it already comes with a default configuration for all the IPS standard attributes. Additionally, we have the capability to incorporate custom attributes or client required attributes according to the client needs. And this can be also used for tagging configuration as well. Okay. So next screen will be the title box and revision table configuration. Okay, this screen can configure the title box region, enabling us to detect the required title box information or attributes. Okay, so the next screen will be the custom attribute configuration. This screen already includes also the default attributes designed for use in the project list view, particularly when filtering document files and other information. Additionally, it enables end user to incorporate custom filter attributes tailored to specific project. And lastly, the CAD configuration. So this is an important configuration that manages connectivity and other parameters for CAD conversion, as well as MTO or IPS standard deliverables. This configuration support three CAD systems. First is the PPID, the second is the AVEVA PNIDs, and the third one is the AutoCAD Plan 3D. Okay. Once we complete this configuration, we can click Save and Exit. Okay. So this will now create the project model. Okay, this is the project model. Okay, if we click this project model or the project dashboard, it will go directly to the project list view. This interface will be used for filtering files, this one, and other information as well, includes uploading and processing of the data. So in uploading, click this upload button here. So when uploading documents, it is essential to select the correct discipline and document type information, as it supports two different pipelines. Okay, as mentioned earlier in the project setup, we have configured two types of disciplines and discipline type. So for this demo, we will be using PDF, and this will be used for or the supported by process engineering discipline and document type. Okay, so two ways to upload files or PDF on the screen. Either you can click the screen, it will go to the projects folder structure where you can browse or select those PDFs that you need to upload. Also, you can drag directly the PDF on the screen. Okay, for example, this one. Okay, so once you drag this PDF, it will be uploaded in the screen, but not yet in the database. If you click the upload button, it will be directly going to the back end of the database. Okay, so approximately it will take 15 to 20 minutes, seconds, the files to be uploaded in the back end. Okay, you see, it is automatically processing. Okay, check. Okay, so this is the file looks like when this uploaded in the backend. It will show the status as gray, means the files has been successfully uploaded and ready for processing. Okay, when processing files, okay, so when processing the document files, the default AI-based model will be will be automatically integrated or plugged in the database, providing initial component detection based on the unified model. So, okay, for the unified model, we have already enhanced this model. We have already supported 6 different standards, including BIP. Okay, so when processing this one, you can click this button, which is automatically supported the searchable processor. But for your information, we have actually 4 text processor. One is the searchable, which supports searchable PDF. The second is the AutoCAD text, which is PDF printed directly in the AutoCAD, which has this AutoCAD ECX format. And the third one is the non-searchable text, which supports the scanned PDF. And lastly is this PPID dump Excel, which is in Excel file format. Okay, so for this demo, we'll be using the searchable text. Okay, so we will show to you the actual process file. So this is the actual process files. If you can see, the status is already green, which means the data has been processed and the unified or the AI-based model is already implemented. Okay, by checking that detection, you can click this action here and go to interactive UI or interactive user interface. Okay. Okay, so before I discuss the purpose of IUI or interactive user interface and its AI component detection results, I'll be showing 3 model interface. Okay, one is the AI mode. Okay, AI mode will show you the actual AI detection based on the default or unified model. Okay, you can see this one here. This is the detection. The second one is the IUI mode. IUI mode where you can update or modify any false detection based on the AI detection. Okay, but generally the detection will be coming in the AI mode. Okay, and lastly is the process mode. Process mode where you can see all the connectivity and other attribute propagation. Okay. Okay, so let's back in IUI. So IUI mode or interactive user interface is one of the main features of this product. This user interface allows the end user to do correction based on the AI data detection. Okay. Okay. One of the feature also for this product is the editor. Editor is this feature allows the end user to review the detection location of each component along with all the associated link attributes for these components. So for example, we have this detection. Okay, so before actually this already clean data. But if you go to the actual detected data based on the unified model, okay, so I will give you an example. Okay, okay, this one. Okay, if you see this signal lines, which is electrical signal, you'll see that the detection for this one is not completely capturing this vertical line. Okay, if you see also these green boxes, it's represent the bounding box or the symbol bounding box. Okay, if you see also this color, it's represent or you can refer to this left panel of the screen. Okay, it shows the component hierarchy, which all the shows the component categories, including the subcomponents for each categories. For example, for piping component, which the subcategory will be fittings, PS items, OPC, valves, and line breaks. Okay, this color coded here is also represented here in the bounding box. Okay, so one of the example here is this control valve is not being detected in the unified base model. So what will be happening here is in IUI. Okay, we can correct those undetected component. Okay, see here. Okay, this is now the corrected data in IUI. If you can see, previously this vertical bounding box for instrument line is not fully detected this line. So now you can see it's now fully detected, including the control valves. Also, control valves contains the attributes. Okay, this is the IPS standard attributes for example for this ZB or prefix and loop number as well, also including the failure data. Okay, so when you click this bounding box, you will be directly taken to this property table. This property table is one of the feature also that you can update the data. If example, if you want to update this prefix, okay, you can also directly change this one, and this will be updated in the IUI mode. Okay, so as mentioned earlier, we have also this editor. So editor will show to you the actual component detection and the graphics as well. So example for these valves, okay, this is the actual graphic detection. Okay, if you click this example, this detection one for the gate valve, okay, it will be directly taken to the original location of the component. Okay, you can also update data in this editor. Okay, you can disable this view thumbnails for you to easily um, locate those attributes. So attributes are being displayed on the upper of this editor. Okay. For example, if you want to update certain attributes like sizes, if you want to update, example, if there's sizes here that are not detected, you can easily update that range. Okay. Okay. So once this editor is being or the IUI is being cleaned, okay, we already cleaned the data. So lastly, we will do the update for this one. So basically, the update will push all the IUI or modify data on the back end. Okay, so let's go to the deliverables. Okay, so deliverables, you can click this one. So this is the deliverables screen. It's loading. It's processing in the back end. But yeah, deliverables where you can review all the relevant attributes for each component. This reports template follows IPS standards, but we can customize it because on the client's requirements. Moreover, a significant advantage of this product is that after cleaning the AI data through the IUI interface, you can promptly download components reports based on the information from the PDF or the drawing PDFs. This eliminates the need to wait for SPPID or AVEVA drafting completion to extract reports. Okay. You can see also 8 supported components here from line list, instrument list, control valves, safety devices, up to fittings. So for example, for line list, we have already established here the to and from data. Okay, this one. And also for the inline components like control valves, it also established here the parent tank as well for the line connected. Okay. Okay, so once the deliverables is completed or done reviewing, you can go to the CAD interface. Okay, so CAD interface, we do not only develop the AI pipeline, but also establish the dedicated pipeline to manage connectivity and piping networks for each component through algorithms. This interface enable us to extract various input data for multiple CAD systems. Specifically, it can extract loading sheets in Excel format for PPID, XML format for AVEVA PIN-ID, and JSON files for AutoCAD Plant 3D. Okay, so before we extract AVEVA PIN-ID, we have two required files to be loaded in the UI or in the backend before we downloaded the XML files to be consumed in the AVEVA conversion. One is the library mapping. Okay, this is the library mapping we use. Okay, library mapping will be used for converting the IPS data from IPS unified JSON structure going to the destination CAD system. Okay, also the shape catalog. Use the shape catalog. Shape catalog will be used also for AVEVA conversion, and this will be exported directly in the AVEVA PIN-ID environment. Okay, so let's back to the product. Okay, so we will click this AVEVA PIN-ID. So in this product, AVEVA PIN-ID or the XML generation will only take less than a minute. Okay, you can also download bulk XML files. If you have 1,000 XML files, you can download in a single download, and it will take only less than 3 minutes. Okay, so let's okay, this is now the XML format. Okay, yeah, this is now the consolidated data. Okay, so let's go to the actual generation. Okay, so before we import the XML file that we downloaded in the system or in the product, okay, first is we need to create the project in the AVEVA. Okay, and then once the project is created, okay, we'll go to this screen in the AVEVA PIN-ID. Okay, just simply do the right click for this project. Okay, and then import drawing from XML. Okay, and then you can browse the XML file that you downloaded earlier. Okay, for this example, XML file, and then click the XML format and run the drawing. Okay, so based on our benchmarking for this importation, approximately it will generate less than 2 minutes. Okay, but it also depends on the dense of the drawings or data. But normally it is not it will not generate 5 minutes or more. It will less than 5 minutes. Okay, for this one it will generate less than 2 minutes or 1 minute actually. Okay, so if you moving forward to this one, once the importation is generated, you can also see this output based on the XML file. Okay, you can see. Okay, also the data is coming. Okay, if you check the line number here, okay, if you double click this one, okay, all the data is also populated in the AVEVA, like the sizes, the area number, and the specification. Okay, as well for the let's find instruments here. You click the instruments. Okay, yeah, it's also show the data, for example, for tag, number, or prefix. Yeah, let's find components here. Yeah, equipment as well. You click the equipment. Yeah, this one. Okay, so basically, this is the actual generation or the generation output in AVEVA. Okay, yeah. I think this is the last screen, JK.
Yeah, thank you, Dennis, for the lovely demo. And Benji, can you share back the slides? Before we get to the slides, just a quick recap. The demo was really great, and as you would have seen, the first was the creation of the MTOs. Many a times the EPCs want to have the MTOs before the start of the project. Sometimes they're given license of PDFs. The licensor hands over the PDFs of the BNIDs, and what the EPCs want is to extract an MTO to get a estimate of the project size, and this software allows you to get that as a first byproduct before you get to the the final CAD system. So yeah, so coming back, I have just a few more slides. Next slide, please. Yeah. So what are the key quality metrics that you see in this AI? I've been always repeating to you that AI can never get you 100%, and that's also not the intent. Depending upon the quality of your input, you can get anywhere between 60 to 80%, and then you need to have this manual tidying up. So if you see on the left, the key detection categories, lines, components, instruments, property data, general text, etc. You have seen a percentage of what is the kind of detection that happens, 80 to 90% for lines, 70 to 80% of components, 80 to 10% of instruments, etc., etc. And on the exception side on the right, you see that you have to add about 10 to 20% of PNID symbols. That is one of the reasons being that some of them may be very customized symbols that are not repeating too often in your drawings, so you need to recreate them. OPCs are generated, but they need to be paired manually. Control wall bubbles, sometimes there are more than one bubble, so you need to create that. Equipment property label table, sometimes table label, sometimes you have to label manually, and sometimes the flow arrow. So these are the key quality metrics that you see as an output from the AI. Next, please. And coming to the most important question on how we deploy these solutions to you. So there are two distinct ways in which we do it. One is a full service mode where we do a complete end-to-end. We create the AI data and then migrate it to your destination CAD system and make it compliant 100% to your requirements. And the other way of deploying it is as a kind of a cloud or enterprise solution where we give access to the cloud to you. We help you with the training the AI model. And finally, the tidying up in QA/QC has to be done by the customer. And yeah, so there are two options here. And in both options, the pricing is on a per PNID basis. So there's nothing like a licensing here. It's all very similar to what you have for character recognition software. So similarly here, we price on a per PNID basis. Yeah, so the value proposition basically, as I said, coming back is how much you save on time and costs and what is your productivity gain, anywhere between 30 to 60%. So this is what is really the aim of the solution. You can see these benefits with higher volumes of drawings, definitely. Next, please. This is the hardware configuration, how you can deploy the solution. You could deploy it on our own cloud, IPS cloud. You could deploy it in your enterprise cloud or your own cloud, or on an on-prem server. Here it mentions all those salient features under each system. Okay, next slide. And as I mentioned to you, we will provide you end-to-end service, right from model creation, AI data cleaning, intelligent PNID generation, full manual correction, and final quality checks. The whole process can be done end-to-end by us. We have got a full-fledged engineering center in Cebu that helps complete these. Equally, we have global partners with whom we work. And if there is a situation where we need to work with your partners, because many big MNC companies have fixed partners and they don't want to change partners. So we are also happy working with your partners for the cleaning activity. Next. We have our center in Cebu, as I mentioned. So this is a Cebu. This takes care of the IP requirements. Does it enclose office space, access controls, clean desk policy, And based on needs of the client, we can provide separate offices with access control for individual clients. Okay. Yeah, that's about it. And our journey continues, and we keep developing software on AI. And as and when we have something new, keep watching this space. We'll get back to you. But as I said, there is a space for asking questions. And let me take a look if there are any. And apologize if I'm not able to take all those questions. Could I directly edit result by myself, AI result by myself, or this is always an IPS service task? Dennis, you want to take this question?
Yeah, can you repeat your question, JK?
The question is, it says, could I directly edit the AI result by myself, or is this always an IPS service task?
No, it depends on the project, JK. But if for the question, yeah, clients have the access or have the rights to
Correct.
update the data in AI.
Correct.
Yeah.
So the also to qualify what Dennis is saying, the actual thing is we give it two options. One is a solution access, where you get access to the solution, and what probably I think you mean is when you take this data into the CAD system, then the cleaning can be done by yourself. Yes, you can do that if you get into that kind of a model of working with us. And alternatively, we also do a full service part. Okay, any more questions you can please raise in an email to us. We're happy to answer you. Thank you for being with us, and I thank the IPS team for the support for this webinar. And yeah, talk to you shortly. Thank you very much. Bye-bye.